Okay, I believe it's time to start. Doris, welcome everybody to today's session of CEBRA Inflation Drivers and Dynamics webinar. My name is Raphael Schönle, and I'm one of the organizers of this new webinar series on behalf of the Central Bank Research Association. Dominic Smith is my co-organizer on this. And since inflation is a very pressing issue, without much ado, I want to pass on the stage to Alexei Krivtsov, who is a really accomplished expert in the field of inflation and a senior research officer at the Bank of Canada, and who will be today's moderator. Alexei, the floor is yours.
Thank you, Raphael. The topic of today's very exciting session is understanding inflation dynamics. And special thanks to our organizers, Raphael Schönle from Brandeis and Dominic Smith from the BLS. Thank you. A few words on the format of this webinar. It is 45 minutes in total, with two presentations of approximately 15 minutes each and 10 to 15 minutes of Q&A at the end. Attendees will not have the option to switch on their audio and video, but are invited to write comments or questions in the Q&A space. Attendees can, of course, pose their questions during the presentation, and they do not have to wait till the end to pose the questions. And then when we get to the questions, I will voice the questions back to presenters. The webinar is live streamed via the CEBRA YouTube channel, recorded and made available on the website and the YouTube channel of CEBRA. Short disclaimer: participation in a CEBRA webinar does not constitute or imply an endorsement, recommendation, or favoring endorsement of the views, opinions, products, or services of the Central Bank Research Association or any other participating institution, individual, or entity. All views expressed during a CEBRA or CEBRA co-hosted event are strictly those of the authors, discussants, and other participants, and not those of CEBRA, the co-sponsor institutions, or any other participating institution. Let me introduce the speakers. The session features Sergio Ocampo-Diaz, who is assistant professor at Western University, formerly University of Western Ontario in Canada. And the title of his paper is How Robust are Robust Measures of PCE Inflation. The second presenter is Pablo Tonello, associate professor of economics at the University of Michigan. He will talk about the dynamics of large inflation surges. And without further delay, Sergio, please go ahead. The floor is yours. You have 15 minutes.
Thank you. Thanks so much. Let me share my screen just momentarily, and I hope everybody can see it. Perhaps you can confirm if that's the case. And so, well, I'm very happy to be here and to join all of you. As Alexei was saying, the title of the paper is How Robust are Robust Measures of PCE Inflation, and it is joined with Raphael and Dominic that were also introduced just a moment ago. This is very much work in progress, and we very much value all of your comments. And so, please share your thoughts with us. I will be happy to address them in the Q&A. So the starting point for this is we're thinking about robust measures of PCE inflation that basically come from the fact that judging the behavior of trend inflation is remarkably hard. Headline, or what we will call inflation just generally, averages all expenditure categories and the price changes of all expenditure categories. But many of these categories in every given month can experience extremely high or extremely low changes. And so understanding how much we should pay attention to these things is hard because oftentimes these changes are only transitory. And so in response to this difficulty that researchers and policymakers have in interpreting what actual trend inflation is doing at any given time, then policy institutions have developed various measures that have been broadly called robust measures of inflation. And the idea behind these measures is we can drop some of these expenditure categories from inflation with the objective of eliminating some of this transitory variation and provide a better message of what is happening to trend movements of inflation. And prominent examples of these robust measures are trim mean inflation that's computed by the Dallas Fed, median inflation computed by the Cleveland Fed. San Francisco Fed also puts out several other measures of inflation, or core inflation that's also often used where specific categories are taken out of the computation of inflation every month. So the objective we have here is, and what we're going to do is we want to reevaluate these robust measures of inflation, in particular measures of inflation that fall under the category of trim mean measures. And so we're going to do that in 3 steps. First, we're going to construct long series of PCE inflation. These are going to go from 1960 to the present day. So we're going to include in today's presentation the last release of PCE inflation that covers up until October 2022. That's going to increase the length of the usual series we have for robust measures of inflation by about 40%, by including that initial period, 1960 to 1977, which is when these robust measures of inflation start. Now, having done that, we can then go and reevaluate what are these properties of official trim mean and median inflation. I'm going to be clear about the definition of these two in a moment. And we're going to find that even though they generally commove, there are substantial disagreement in many months. And we're going to find that in terms of capturing the behavior of trend inflation, trim mean is slightly better than median, but these differences are relatively small. I'm going to be clear about that as we move on. Then the third thing we're going to do is we're going to consider alternative trim mean measures. So we're going to deviate from the official measures of trim mean and median inflation, and we're going to choose the trims for trim mean measures so as to capture the behavior of trend inflation. And when we do this, what we're going to find is there's actually a wide range of trims that delivers very similar prediction error over time, so that their average prediction is very, very similar, even if you change the trims quite a bit. However, within those trims, even though they perform equally as well in terms of predicting trend inflation over time, in any given month, there is going to be wide variation in the level predictions that they provide. And so we see these as a signal that when we're thinking about robust measures of inflation, we shouldn't be constrained to a single trim and kind of marry ourselves to here is the best trim that we find. And so we're going to use that one, because there's actually there's a range of trims that are going to provide very similar prediction error, but that amongst them, they can still vary a lot in terms of their prediction. In doing this, we're also going to find that these trims, the ones that perform best, are slightly asymmetrical, and they are generally higher when you worry more about the behavior of future trend inflation than when you worry about the behavior of current trend inflation. Now, if you were to just like log out for some reason, this is the slide that you should like take away from this. Here is like all of our results. Now, I'm going to proceed. We don't have a lot of time, so PCE inflation data, this is going to be the data we're going to use. This is personal consumption expenditure data. This comes from the national income and product accounts that are produced by the Bureau of Economic Analysis. We're going to be considering today data for the US. This is the preferred inflation measure used by the Federal Reserve banks, but also this is a measure of inflation that's going to be consistently revised backwards. So we're going to have a consistent measure since 1960 to 2022. So we're going to extend this series. Official trim mean and median series only start in 1977, mostly because that's the year where computers are first introduced into the PCE. We're going to use historical data to be able to extend this backwards. That's going to give us a longer sample to work with. But also importantly, it's going to give us a longer sample that's going to include more periods of rising and high inflation, something that's relevant now, and that the initial like standard official series that goes starting in 1977 is going to have more of a trouble having like these historical events with high inflation. Okay, with this data, what we want to do is we want to consider trim mean inflation series. So I want to be brief, but I want to give you the precise definition of what we're going to do. In this trim mean inflation series, the objective is to remove a percentage of expenditure with the lowest and the highest inflation. So we're going to remove the alpha percent of expenditure that has the lowest inflation rates in any given month, and the beta percent of inflation with the highest inflation rates in any given month. Then we're going to take the remaining series of individual expenditure category prices, and we're going to weight their monthly inflation rates. And then we're going to concatenate these trim mean inflation rates to get a yearly inflation rate. That's the number that I'm going to be showing you later. So that's going to be our definition of, not our definition, but that's going to be the definition of trim mean inflation series. And that's going to be what we're going to be using going forward. Now, there are two particular examples of official robust inflation series that are themselves trim mean measures. The first one is Dallas Fed Trim Mean Inflation Series, where they trimmed the lowest 24% and the highest 31% of inflation categories. And they obtained this trim by trying to predict trend inflation in a sample going from 1977 to 2005. So as a byproduct of what we're going to do later, we can reevaluate these particular trims and see how optimal they are. The second one is the Cleveland Fed median inflation. This is going to be equivalent of trimming out everything and leaving only the median inflation category every month. So that's the same as having alpha and beta being both equal to 50%. In doing these every month, there are different categories of expenditure that are being excluded. We, in our revision of the paper, we're going to go more into detail about like what are those categories. But you should know the categories that are most commonly excluded are not so much gas, but food items that tend to vary a lot, either with upward or downward swings in their prices. Okay, so this is about like what we're going to be using. Doing that, we get this very long series starting from 1960 to 2020, 2022. Here we're plotting headline, median, trim mean, and also core inflation as a benchmark. What we take away from having computed this long series is mostly the following. This series actually differ quite a lot from what headline inflation is doing. That might be a good thing or a bad thing, depending on what we think trend inflation is going to do. But then not only they differ a lot from from headline inflation here in blue, that's going to be the blue line headline inflation, but they also differ a lot from one another. The average range between these series, between the lowest and the highest robust measure in any given month, it's about 0.85 percentage points. That level of disagreement, it's going to come back later when we talk about how very different types of trims can deliver the same prediction error. They can both perform basically as well, but they can still deliver very different level predictions for what we're doing. So this is going to be the main takeaway at this stage, where we're just extending this series back to 1960. Now, if you notice, prior to 1968, there are a lot of series that will provide very low levels of inflation that you see here at the very beginning of the sample. That is because a lot of the individual expenditure categories were not updated frequently up until the late 1960s. So going forward, I'm going to restrict the sample to start in 1970 when I conduct the exercises in trying to tell how well these different measures of inflation are tracking trend inflation. Okay, so I'm going to be restricting myself to 1970 onwards, but the data is there starting in 1960. So what's going to be the objective now that we're going to reevaluate this robust measure of inflation? We want to know how well they track current and future trend inflation. When we say current trend inflation, we mean specifically a center moving average that gets the center moving average of headline inflation 16 months ahead, 16 months backwards. We also have exercises where we use a bandpass filter with basically identical results. When we think about future trend inflation, we think of a moving average that takes all the inflation of the months 12 to 24 months ahead of the current level. Now, this, of course, is an ex post measure of trend inflation, but it is consistent with what the literature has done earlier when evaluating the performance of this series. We're going to do these in 3 different samples. We're going to consider our full sample, 1970 to 2022. We're going to consider a sample in the 70s and 80s when inflation was way more volatile and way higher. We're going to consider a recent sample starting in 2000. And the numbers I'm going to show you next are going to be the root mean square error of the different robust inflation measures with respect to predicting the whatever the target is for trend inflation. What do we find? Well, when we're trying to predict the current trend, trim, mean, and median do way better than not trimming. If you wanted to get at the trend or smooth behavior of headline inflation, trimming is a good idea. But not only that, trim mean is slightly better than median, but I want to emphasize that these differences aren't very large. Even though trim mean performs better than median, the difference is not very high. When we look at our other samples, the 1970 to 1989 or 2000 onward sample, the same message arises. Now, trim mean is not always best, but it is generally better than using median. But then again, the differences aren't substantial, except perhaps in this case of trying to predict current trend in the 2000 and onwards series, where the differences are slightly higher. But the main message remains. They produce very similar results in terms of their root mean square error, and they are way better than just doing no trimming. But then the third point that we raise is, can we do better than this? Can we actually just choose optimally these trims and get a different answer? Well, here, that's what we're doing. We're going to consider all the possible trims. And by doing so, we're going to try to find a trim that's going to minimize this root mean square error. Now, what we find is that these optimal trims are actually quite different when trying to predict current trends from the ones used officially. So we find an optimal trim of lower 20, that's going to be alpha, and a beta of 22, that's going to be the upper trim. But when you compare the root mean square error of the optimal trim, even though it has a very different trim, to say, for example, the best root mean square error across the two official measures, that's going to be the Dallas trim mean or the Cleveland median, the differences are, again, relatively small. So you don't get a lot of gain from doing this. Now, what you do get is the sense that you can move far away from the official trims and still kind of produce a very similar error. Now, to just conclude, because I know we don't have much time and I actually cannot see the time right now, I just want to show you, and sorry, let me skip this. If you do it in the other two samples, the same message arises. Trims are quite different, but differences in root mean square error are rather small. I want to end by showing you this graph. What we're doing here is we're plotting the root mean square error of all the possible combinations of trims. So these levels are different lower trims. The vertical levels are different upper trims. The 45-degree line will be a symmetrical trim, where you're trimming, say, 20% below, 20% above, 30% below, 30% above. What you're seeing here, the bluest areas are going to be the ones with the lowest root mean square error. If you concentrate on those, what you see is that there is actually a wide range of trims that all produce very similar root mean square error. Even though the optimal one is here at the star, they are all quite similar. I don't have time to show you this, but if you look at, say, for example, the best 50 trims, they actually differ quite broadly in terms of their level prediction. So that's going to be basically something like this. If I select all the best 50 trims, there's going to be a range of about 40 basis points between the predictions for current inflation that you get from them. That's going to be all the time I have. There are more exercises we conduct and there are more things we do. Let me just conclude by saying what we do in this paper, we extended robust measures of inflation back to 1960. We want to evaluate their performance. We actually find that official robust measures are near optimal at matching trend inflation. But even though they perform nearly as well as the optimal trim, the average prediction error hides very substantial differences in what at any given month various candidates for best trim will produce in terms of the prediction for trend inflation. So let me conclude with that. I might have gone over time just a tiny bit, so I apologize to Pablo and to Alexi, and I'll let Pablo go on.
Thank you, Sergio. Pablo, please go ahead.
Does everyone see my slide?
Yes.
Perfect. All right, so thank you very much to the organizers for inviting us to participate into this very interesting and important webinar. The paper I'm going to present today is called The Dynamics of Large Inflation Surges, and is joint work with Andres Blanco and Teresa Ranosova, who is an excellent student on the job market at Michigan. The motivation of this paper is that the 2021-2022 US inflation surge brought back inflation stabilization policies to the centers of the stage. And a key concern that arises among academics and policymakers is the possibility that the increase of inflation that we are experiencing ends up being persistent and that long run expectation inflations end up an anchoring that is departing from monetary authorities' target. This is a concern that has been raised worldwide in both, again, by academics and policymakers. So, a key question that arises in this context is what is the set of policies that can credibly lead to fast and durable disinflation? Okay, so to contribute to this debate, our approach was to study the international evidence on episodes of large inflation surges, and I'm going to be precise defining, but the idea is to measure the recent history on the last 3 decades of episodes that are somehow comparable to the one that we are experiencing now, study what are the salient threats during these episodes and what central banks or monetary authorities do in response to this type of inflation. Okay, what we find is kind of 2 main takeaways is that one, that the current concerns raised about inflation persistence and an anchoring of inflation expectations are echoed in recent international experience. And second, that government responses tend to depart from the textbook prescription of policy rules about how to respond to large and persistent increases of inflations, and instead are consistent with something that can be described as a fear of tightening or lack of increases of real interest rates or fiscal adjustments in response to this large and persistent inflation. Okay, so our data has 2 key components. The data that we're going to use for this historical analysis of inflation surges has 2 key components. One is macroeconomic data. The macroeconomic data comes from standardized sources such as WDI and WIO, DIS, and national sources also to measure interest rates. And with this, we measure CPI inflation, real GDP, unemployment, fiscal balances, expenditure, etc. And something, and with interest rates, we try to go to local sources as well. And then the second block of our data is from inflation expectations. We're using data from Consensus Economics, which is an international survey of professional forecasters that has a large span and that spans many also countries across the globe, and that has available data since 1990 to 2019, which is going to be our period of analysis. Okay, so we have 55 countries. 23 of these can be classified as developed market economies, 32 as emerging market economies. And our data on expectation is going to have 2 components. One, the 1 year ahead inflation forecast that we refer to as short-term inflation expectations. And second, the 5Y forward ahead forecast, which is how much inflation you expect for the next 5 years in 5 years. Okay, so it's the measure between years, the average between years 6 and 10. Okay, so with this data in hand, we need to have an empirical definition of what is an episode of a large inflation surge. So for this, we compute the histogram of inflation changes, putting all of these countries in all of these periods, and this is again CPI inflation, annual changes of inflation. And once we have this histogram that is plotted here on the left of the distribution of inflation changes, we can focus on the tail of these distribution, and that defines a threshold of inflation above 2.2 percentage points. Okay, we also study alternative robustness, and we see how the results vary when using other thresholds. Now, if we focus on these threshold on the top 90th percentile of the distribution, that is equivalent to a 3.4 percentage point initial increase of inflation in the first year of this inflation surge. Okay, we also consider larger episodes as well. And here on the plot of the right, you have the evolution of inflation surges with this definition. And what you can see is that these empirical measures captures fairly well the great inflation of the 1970s. For example, that we have here several inflation surges occur in this period. More recently, we also have an increased spike of inflation surge episodes that occurs around the global financial crisis of 2008. And you also tend to see that over time, developed economies, which are here the gray bars, have become less frequent in terms of inflation surges, which is consistent with the stabilization that these economies experienced over the last decade. All right, so this is kind of our empirical definition of what an inflation surge is. We have more than 100 episodes in our period of analysis, which is the one that we are going to be studying. Okay, so then we estimate the following empirical model, which is aimed at documenting the dynamics with an event time type of methodology of macroeconomic variables of interest during these episodes of large inflation surges. And for this, you consider the following. So take some variable Y for country I in period T. Okay, so we estimate this with panel data. And we are going to project this variable into a country fixed effect to absorb permanent differences across countries. We have several lags of the variable of interest. And then we have leads and lags of a dummy variable that takes the value of 1 in the first year defining an inflation surge episode. Okay, so if you have that, for example, Brazil experiences an inflation surge in a particular year, that's going to be that this dummy variable takes a value of 1 in that particular year. All right, and then we have leads and lags of these variables, and with these estimated coefficients, we can trace the dynamics around inflation surge episodes for different variables of interest. For our baseline episode, we take kind of 1 lead and 4 lags, but we also, the results are robust also to reach our lead and lag structure. Okay, now this is an empirical model that we estimate. Now what I'm going to show you is different sets of results that come from the estimated coefficients of these models. Okay, so first of all, let me concentrate on the figure on the left, which shows the dynamics of inflation, of CPI, during these episodes of large inflation surges. So I'm going to show you many different figures like this. So let me kind of go slow on how to read them. So on the horizontal axis, we have years following the surge. And on the vertical axis, we have variables of interest, in this case, percentage points for inflation. So these are plots obtained from the coefficients estimated in the previous model. And the idea here is that t equals 0 corresponds to the first year of an inflation surge. We're tracing the average dynamics around the inflation surge. Okay, so you have like in t equals 0, what was the average dynamics of inflation? And then you have years after the inflation surge in the horizontal axis, and then you have here what happened before that inflation surge, before the start of the event time at t equals 0. Okay, so that's kind of how to read these figures. And what we have on the left panel is the dynamics of inflation during these episodes of large inflation surges for our baseline sample. Goes from 1990 to 2019. We see that on average we have an inflation surge of 4 percentage points in the first year of the inflation surge. And then we have a disinflation, but something that is interesting here is that the disinflation takes a long time. Okay, so these are 8 years after the surge, and you see that still inflation is above its pre-surge levels. Another way of seeing at this, if you take the average of the number of years that it takes for disinflation compared to the number of years that it takes for inflation to increase, it tends to take 3 more number of years to disinflate than it takes to increase inflation. Okay, so in that sense, is that the first takeaways that we have from this analysis is that inflation surges tend to be persistent. And this is something that we can also estimate in the pre-1990 sample. We do that excluding hyperinflations, but you can see how the dynamics that we document for our episode also has some external validity for the pre-1990 sample, both for developed market economies, which are here the dotted black line, and for emerging markets, which are the solid green line. Okay, that's a kind of our first fact that we document. Now, the second and third fact had to do with inflation expectations. So the first thing that we say is to say how expectations evolve in these episodes, and we can measure in this data that we have for expectations, we can measure the average and the standard deviation of inflation, 1 year ahead inflations across forecasters. So we tend to see an increase of inflation forecast, 1 year ahead forecast, and also an increase in the discrepancy across forecasters. But that's much slower than the actual increase of inflation. Okay, so a way of seeing at these is to looking at something that the literature on inflation expectation has studied, which is the 1 year ahead inflation forecast errors. Okay, so for each year T, we compute what was the realized inflation in that period minus what forecasters were expecting for that period. So you see, if you trace that inflation forecast error, is that inflation surges were unexpected, as measured by the fact that you have an increase in the forecast error of the roughly the same magnitude as you had of the increase of inflation, and then that these forecasts gradually catch up. Okay, so 2 years after the surge, the forecasters are already incorporating that inflation expectations are higher, and that is aligned with the actual realized inflation. Okay, so then the third fact that characterizes these episodes has to do with long-term inflation expectations. Okay, what we tend to see is that long-term inflation expectations tend to exhibit persistent increases. Okay, now again, in the left panel here, I have the mean across a forecast and the standard deviation across forecasts. The blue is that average, and the dotted line is the standard deviation. So what we tend to see is that there is an increase, there is a significant increase in long-run inflation expectations measured with the 5Y inflation forecasts, and that increase remains persistently large throughout the episodes. So you can say, okay, how large is this increase? Because in principle, this is 0.25 percentage points. So on the one hand, it doesn't seem like a very large number, but a way of measuring this actually compare to the actual inflation, that if you were to use our model to forecast what is the dynamics that you have forecast forward for inflation you would have. Well, what you see there is that long-run inflation expectations tend to increase less than actual forecast increase, but they tend to remain persistently large. Okay, so the long-run inflation expectation exhibit a similar dynamics than short-term inflation expectations in the sense that they do not react immediately. So there's a sense in which there is not more an anchorness because forecasts react slowly, but then after they increase, they remain persistently high in a way that is aligned with what actually end up happening with long-term inflation. Okay, that characterizes the dynamics. And overall, I mean, if I were to summarize it, it's like a persistent dynamic of inflation. So now the question that remains is, what do policymakers do in this context? And here we are tracing the dynamics of short-term interest rates and fiscal balances to GDP. On the left panel, we have the nominal rate in blue, and the dotted black line shows the real interest rates. And this real interest rate, and I think about having long inflation expectations, is that we can use inflation expectations to measure the real rate with those inflation expectations. So we tend to see that monetary authorities do increase nominal interest rates following these inflation surges. So there is spikes of interest rates that actually remain persistently high after there is the inflation surge. But when you measure it in real terms, you do not see that real interest rates increase in response to these large increases of inflation. Okay, and similar occurs for fiscal balance. We observe that if something fiscal balances deteriorate right after the increase, the inflation surge, and they only improve kind of 3 or 4 years after the inflation surge. Okay, so in that sense, our evidence suggests that episodes of large and persistent inflation tend to occur in periods in which government responses depart from the prescription of policy textbook that will prescribe that when you have an increase in persistent inflation, you would raise real rates. And instead, I think a kind of a way of framing the policy response is in the Calvo and Reinhardt idiom that we observe some fear of tightening, and that monetary authorities choose not to tighten monetary and fiscal policies. So in the paper, we have the dynamics of output and unemployment rate. We see a contraction of economic activity and an increase of unemployment rate following the surge. So potentially one explanation of why countries do not tighten more real rates or fiscal balances is because they are concerned for economic activities. But again, this is kind of a departure from the standard policy prescription, and is consistent with the evidence that we have from the US in the pre-Volcker period. For example, Clary and Galli-Gerter have documented that is, if you estimate the policy rule for the US, that's what you observe in the pre-Volcker period for the US in the run-up of the inflation of the 70s as well. Okay, I don't have time to show you these. We have kind of many more robustness in the paper of different exercises that we do. One that I do want to mention in 2 minutes is that when you do inflation surges of a larger magnitude, so for instance, if you pick a threshold of 4 percentage points instead of 2.2 percentage points, you do start observing a much larger an anchoring of inflation expectations, with long-term inflation expectations now increase 1 percentage point above their pre-surge levels. Okay, so the size of the inflation surge also matters for the anchoring of expectations. Okay, so to conclude, the paper documents stylized facts that characterize the large inflation surges observed worldwide in the last 3 decades. We find that several concerns raised during the 2021 and 2022 surge are echoed in the international experience, and in particular, the persistence of inflation and the unanchoring of expectations. And then a question that I think the paper that will be interesting to analyze going forward is, why do governments do not appear to tighten monetary and fiscal policies more aggressively in response to these large inflation increases? A potential consideration could be economic activity and unemployment. But the weights that central banks seem to assign in practice, at least during these episodes, to these objectives seem to depart from the standard weights that we have in textbooks such as Woodward and Galli. Okay, now we leave the combination of these models with empirical evidence for future research. Thank you very much.
Thank you, Pablo. We'll jump right into questions. We have about 9 minutes. The first question from Luigi Palombo. How consistent, I think this is to Pablo, how consistent is defining that before an inflation surge, there is an inflation dip, if that's correct reading of the chart?
Yeah, that is correct. The dip is it's substantially smaller in that sense. But I mean, the main reason to analyze that, if you want, is to try to see that we're really capturing a surge, if you want, right? So there is a smaller dip, but if you want, the surge is much larger than the initial decline is. I mean, it's an interesting fact that comes out from the dynamics as well. For us, what was more important is that we didn't have, like, if you want, that this was a long phenomenon that was building up. But I agree that it's interesting to measure, to focus more on this as well. It's a good point.
I'll ask a question from Rafael as well to you, Pablo. So there's 2 questions. I'll take one for now. What do you find if you differentiate between periods where demand and where supply shocks dominate?
That's a very interesting question. So there's a sense in which we deliberately analyzed surges in a more descriptive fashion. So we wanted to have facts that were descriptive and were imposing as less structure as possible. Now, I agree with you that it would be nice to put a bit more structure and to enter into supply and demand. That's something we have not done. I think it's a very good suggestion.
Before I get to the second question, Rafael, on which I also had a version, I wanted to encourage everyone to ask Sergio questions. And while people do that, Sergio, I wanted to ask you, it's more of a clarifying question. You kind of evaluate the empirical success of your trend inflation measures by looking how well they predict the trend inflation, which you define as some kind of smooth object, right? The question is, because trimmed and median, they themselves kind of, it's a smoothing of the underlying series, right? And I mean, it seems that they mechanically, they're supposed to fit or even forecast maybe your definition of the trend inflation. So I'm just wondering how much of that is that, as opposed to some kind of more a more fundamental measure of their empirical success. Does that make sense?
Yeah, I'd like to perhaps answer in 2 steps. The first one is, we actually wanted to be very hands-off in terms of coming up with our own measure of success. And so we're following what the designers of these robust measures have used as a measure of success. And we're saying, well, with your own measuring stick, this is what's happening. Now, the thing that I think it's relevant from our results is not so much the fact that both trim mean and median outperform just using headline. That I agree is a little by construction. The objective is a smooth version of headline inflation. These also in some ways smooth out. And so it's no surprise that like you're gonna outperform just using the more volatile measure in order to track it. That's to some extent by construction. What we were not expecting, and what I think it's a bit more relevant, is the fact that the exact way you're trimming doesn't seem to add a lot to reducing that forecast error for that smoothness. Even though we already know that trimming, the various trims we're considering are actually quite different, right? Like if you think about median, you're trimming everything but one series every month, and you're keeping only the series with the median inflation. Dallas is trimming the 24%, 31% with the lowest, highest inflation. The one we find performs the best trims 20 and 22, but all of these are producing very similar root mean square error. And so I think that the part we find more relevant is not so much that they produce a root mean square error that's lower than just using headline. That I agree is by construction, but that once you start trimming, we find a wide range of trims that perform relatively similarly given these target, this measuring stick. That's the measuring stick that has been used before when defining these robust measures. But then when we look at how these different trims perform in terms of implying, what series do they imply, there are substantial differences in the levels they imply. So you're making different mistakes. Those mistakes tend to be kind of equally as good or equally as bad, depending on how you want to look at them. But then the levels are quite different. And so relying on only one of them, like if I were to tell you, oh, I did it, and it's 20 and 22, that those are the numbers you need to use, I'll be ignoring half of our results. 20 and 22 are the best numbers, but then a trim that's like 23 and 25, it's not that different really in terms of the root mean square error, but it will imply a different level. And that's a little bit the picture I show you. I flashed you at the end. I saw it because that was a bit rushed, but I think that's where I will go up a bit more. It is by construction that you outperform headline, sure, but the performance of different trims one and another in terms of tracking this smooth line, I don't think that's a bug introduced by the objective function. I think that's actually something relevant in terms of how we think about how we're trimming and what type of robust measure we use.
Okay, thank you. Pablo, question from Bruno Momont. Is there consistency in which components of the inflation basket are responsible for the persistence of inflation? This could also lead to absence of the observed persistent effect in certain episodes.
That's a very good question, and I think it also connects to the empirical design that we chose. So, given that we chose to analyze 55 countries since the 1990s, there are some more data limitations of going finer. So that's something we could definitely do for some particular countries in which data is available, and it will also be a nice extension. I mean, our main, if you want, objective was kind of characterize the macro patterns, and in particular to see the policy response. I agree that insofar as monetary authorities respond to certain components more than to others, that something also affects the results. So thank you for the suggestion. I think it's a very good suggestion.
And the second question that Rafael had was, it appears there's a shortfall from what the Taylor principle would prescribe for
yes, exactly.
Rates.
So that is one of them. Yeah.
Go ahead.
Yes, exactly. Thanks for bringing that up, because that is, if you want, one of the main conclusions that we have from the study. We were initially surprised by how little real interest rates increased relative to what the textbook Taylor principle will predict. So when I'm saying that our finding is that monetary authorities depart from the textbook example, I am referring particularly to the standard Taylor rules and the standard Taylor principle, that is what we tend to see during this episode.
And the follow-up on this, I guess, is that if they are guided by the fear of principle, the fear of tightening here, right?
Mm-hmm.
Does that really pay off, right? In a sense, if you look at the data, what you see in the aftermath of this, if they're afraid of doing that, does it help? Does it seem like there were the success in terms of soft landings as opposed to hard landings? You know, does it look like it was justified, this fear, or not? You know, what do you see?
Yeah, it's a very good question too. So at some point we were trying to think about exploiting a bit more the cross section. There is also kind of a trade-off there in terms of the identification across episodes will be more challenging, kind of to try to say something about the cross section. That is why we prefer to provide these patterns and then to say, you know, for example, if you want to answer that question, then perhaps you can do it with a model and have and use these measurements as to discipline the model or to inform the patterns of the model. But definitely what you're saying is a question that we were asking ourselves. If you want, for the time, we stop at the descriptive level, right, and we try to be you know, as descriptive as possible. So that's what we stopped before answering that. But we were very curious about that.
Yeah, unfortunately, we're out of time right now, and I'm forced to close this down. Pablo, I would encourage you to reach out to Bob Tetlow, who has an interesting question. But our seminar ends at 45, and we are at 46. So I want to thank everyone, participants, presenters, and participants for their questions, and looking forward to future events.
Thank you so much for everyone. Thank you.
Thank you.
Thanks.